Okay, everybody, today we're going to talk about prime factorization. So with prime factorization, we're going to use our knowledge of factor trees. So we talked about factor trees in our previous video. And so, for example, if we took 8, oh, let's change our color here. If we took the number 8 and broke it down into its prime factors. So 2 is a prime factor. 2 times 4 was 8, but 4 is not prime. So we're going to break it down again into another factor pair for 4. So 2 is prime again. So with this is the fancy word here for prime factorization. So you look at the word prime, right? And these are all of our prime numbers. And then factor is in here. So all the prime factors that multiply to get 8. So we talked about this a little bit in our last, if you watched the factor tree video, that if you take these prime factors that you break down the number in your factor tree, they actually equal the number that you started with. So 2 times 2 is 4. 4 times 2 is 8. So if you look at this number is the same as that number, right? So let's try another one. So if you can, so the breaking down that word prime factorization, so definitions we've already had before, that's going to help us remember what to do when we get to these numbers. So let's try let's try 24. Okay, so we're going to break down 24. So there's so many factors of 24. I'm going to choose 6 times 4. So I can break down, oh, I didn't mean to do a different color there, but we can break down 6 into 2 times 3, and both of those are prime, 2 and 3. And then I can break down 4 into 2 times 2, and both of those are prime, okay? Now, if I take these prime numbers here down at the bottom, the numbers that we've broken it down into, 2 times 2 times 2 times 3. Now, we always list them in order from least to greatest. So even though in the way we have them written here is 2, 3, 2, 2, we're going to break it down and reorder them into 2 times 2 times 2 times 3. So 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. Lo and behold, right? And just remember that you can start with any one of the factor pairs that we had that you know about each number. So I chose 6 times 4. You could have done, I don't know, 8 times 3. You also could have done 2 times 12, right? Those are all factors of that number. 8 breaks down into 4 times 2. 2 is prime. That 3 is prime. And then I can break the 4 down into 2 times 2. So as you can see, no matter which factor pair you begin with, whether it's this 8 times 3 or 6 times 4, you're going to end up with the same prime factorization. So 2 times 2 times 2 times 3. Okay? So that is 24. Let's do the number. Let's do the number 21. So if we have 21, we're going to split it out. There's 2 sets of factors, 2 factor pairs. So 1 times 21, which we can't do, that doesn't really help us with our factor trees. The other one we know is 3 times 7. Now 3 and 7, if we look over here on our prime list, 3 and 7 are both prime. So that is the end of our factor tree. So our prime factorization of 21 is just 3 times 7. Okay, so sometimes it's a real short little factor tree. It doesn't have to be super long. Let's do 27. So 27, I'm going to take 3 times 9. 3 is prime, so I'm going to circle it. 9 would be 3 times 3. 3 again is prime. So the prime factorization for 27 would be 3 times 3 times 3 equals 27. So 3 times 3 is 9. 9 times 3 is 27. So that, my friends, is prime factorization. So 2 quick tips to remember is that when you're doing your factor trees, you want to make sure that you are getting them down to prime numbers. Don't leave any composite numbers down at the bottom. And then for your prime factorization, you want to make sure that you are listing them from least to greatest. Okay. All right, guys. Thanks for listening. Bye.